Figure 6.61 lends itself pretty well to the contours and regions. If we sketch this outside shape, pulling up the geometry, then we can grow the parts, grow the features out as needed. This is in metric, and probably the only other thing is how we're going to generate the 6mm oil or hole through the side. So we'll go new, pick the metric template, and then from the front plane, open up the sketch. And we have a limit dimension again, so we'll pay attention to that. Just rough sketching the two inner circles. So the 41.28 and 41.17 millimeters. Our maximum material condition will be the smaller number. I want to go to that number typically, as it's going to create the interference or be able to calculate the allowances. All right, and then 41.64 on the outside. And if we want to denote that, I'll go back to the 41.17. There's 0.11 millimeters difference. So if I set that under the tolerance precision as a limit and give it a plus value of 0.11 tab, I will see the 41.28 as the upper limit of the dimension. Alright, the two outside, I'm going to go ahead and mirror this. So I'm going to do the center point, vertical, infinite length. Again, this is SolidWorks 2020, so the items popping up as we hover over are part of that new. And let's see, that's going to be under the customize. I'm going to say I saw those, and then maybe they were under the options. So for now, I'm going to leave those on. So as we hover over, circle, sketch a circle, click to place the center, and then drag and release. This is also a click-click. So I've been doing the click-drag. If I do a click-click, press, drag out, click again. And then to mirror, I'm going to do a select and a control select, and that will take me right into the result. When we do the next one, we'll pick that up a little bit different. So since this is mirrored, I don't need the half dimension of the 48, so we're going to go for 96. And then the vertical component is going to be related, one of the circles needs to be related back to the origin as horizontal. Then the only thing that's left, if I do the diagnostic of dragging, center points don't move, the circumference of the circle does. So we'll go with a dimension, and that is going to be a diameter of 14 millimeters. Okay, so the next geometry, if we do a center point arc, sketch a center point, use 3 clicks to place the center point. The 3 clicks are the center, the outside, drag in the direction. If it doesn't go the way you want, reverse, come back the other way. Sometimes it takes a little bit of a few rotations to get it to come in to the proper direction. So right now I have inference lines. The yellow inference lines are telling me that I should be picking up tangency, although it's probably not going to infer tangency. So on the little yellow boxes, there would be the tangency for my relation. That would be coincident. In this case, I want the coincidence. Then I will come back, select, hold down the control button, select the tangent. When I let go, the context menu pops up, and then I'll be able to select tangency. So select, control, select, let go, do the tangency, select, control, select, let go, apply tangency, and then select, control, select, let go, apply tangency. Alright, so we need a distance. So this was drawn at the center point, so it shares the that coincidence, that same location or concentricity, and we have a radius of 17. So if I just pick mirror entities, the entities to mirror are going to be the line, the arc, and the line, and then our mirror about is the center line. In this case, we get the preview. And now I have enough geometry to go ahead and build out my my part. So the heights of these are going to be in the features. So I'm going to go ahead, and if we try to pick everything, there's no gaps here. So I can go to region, since I'm not getting a contour to extend all the way out. We'll just pick up those regions, and that is going to be a distance of 14. Alright, so that gives me my first element, and then the sketch being on the same plane as we started with, I can extrude, and contours and regions pops up at the bottom. And mainly you're going to see that anytime the sketch has multiple lines, arcs, anything that overlaps. And if you're not expecting that to pop up, then this is a good time to stop and figure out why. Alright, so we have the 33 on the width. And then one thing of note is that you do want to keep the merge result checked most of the time. If I uncheck that, now I'm going to have a ring solid body, a ring for the flange, and the two overlapping geometries are going to occupy the same space. If the merge result is checked, then it joins this up into one solid body, and the positive into the end of the positive, that overlap has no net gain. It's just still a solid. Okay, so that gives me the geometry. Question is the fillets from a manufacturing. Most of these parts were designed and intended for a casting process. So the fillets were necessary as part of the mold. It was hard to keep the sharps in a sand casting or other casting processes. From a CNC standpoint, I almost want to keep those because another radius is going to bring this up as an additional function, and I'm not going to be able to bring it tight right back to that corner anyway. One of the radiuses I could put in, if this is a stress riser, if it needs the extra load, I could put in the 3mm fillet for the at the base, and I could get that in there pretty easily with the machining process. Not sure why it's thinking about my fillet, but we'll let it complete. And it gets a little complicated in the corners, so I guess that's not too surprising. We're just doing a standard constant size fillet, and at 3mm, 10mm it's going to kind of struggle with it, and it brings it off the edge and goes in. So the manufacturing process, as the designer, I know that that one's gonna, the fillets over this outside edge is going to be a little more difficult. Probably not 100% necessary. If we just kind of buff or break those edges with a file or deburring knife, it's going to be fine. So the one that I missed is the 6mm hole, and so if I go to Control 7, it sort of looks like they're dimetric right now. My choices are, and probably the easiest one will be to select the top plane. And I'm going to look for that inference line that it's vertical to the origin. And we have a distance from, well, okay, that's the diameter, since I missed the line, or missed the edge of the part. And we have a depth, it was from the top, so let's go ahead and accept it. And I just want to see real quick, am I going to be able to drag that to a new location? So it looks kind of weird, but it will let me retain that value if I grab the end point of the extension line, the grip, and drag it to a new location. And then we'll go vertical. Alright, so from this point, Oops, got all my stuff in there. We're going to do a feature, extrude cut, and this can be through all up to next, and have it terminate. Alright, so one of the things I did automatically without even thinking about it was the rollback bar. And so when you see the little fingers on the bar, I rolled it back in above the fillet, and that creates kind of a suppression state that anything I insert will be above that bar. If I want to go with another method, then I can suppress. And my method 2 would be if I need to clock this or have a little bit more control over it, I can create a plane. So we're just going to do the simple offset plane first, and then we'll get a little more complicated as we encounter these side holes on the cylinders. So I hold down the control button, I grab the plane and drag, and then let go of everything. And this is going to be parallel to the top plane, and the second reference will be to the cylinder, and that's going to be tangency. If I pick perpendicular, then it would go to a vertical orientation. So the nice thing about doing this on the plane is that this is going to be a lot easier to manage with the hole wizard. So if this needed to be a counterbore or countersink, tapped hole, some other geometry, let's see, keep the custom sizing values because we made some changes. Let's just go ahead and reset. We'll go back to wherever we were. And this needs to be an ANSI metric. I'm going to be able to utilize the hole wizard on this plane where from the inside out doesn't have that same functionality. So we're going to come down to a 6mm. And custom sizing up to next. We do want to just go through the near wall. It doesn't go all the way through the part, which would be through all. And I don't typically put the near side, far side countersinks. There's times where it may be useful, but for the most part, if we are setting up on any kind of CAM program, the edge break notation is usually enough to take care of it. So I set a vertical, and then from, I'm just going to do it again, from the base, we want to go from the top to the point, and then 13mm. Go ahead and accept it, and now I have a hole wizard item. When I drag the roll back and roll forward, the fillet comes back. There aren't any issues with the rebuild. And then for the plane, I just want to look for the eyeball and hide, so it cleans up the view. We'll go ahead and save that. It took me back to my parts, so I'm going to use the notation. Maybe we'll start adding these out with the names so that we see how it interacts with our drawing template. Okay, so there's our part. This is going to be plain carbon steel, and one required, no finish marks, just the overall. So probably the one thing of note here is I mentioned the mark all for mark for drawing, not mark for drawing. Since this is one that I want to mark for the drawing, we highlight it, or I can edit the sketch, and notice now that this is showing up in black because it is marked for the drawing, where everything else is much. And in this case, could probably use all of those in the drawing, but I may want to add those separately. So we're going to make some modifications as we go, try to improve the manufacturability of these parts, and come up with the correct notations.